What is up, people? We are on page 226. 226, all right? Look, Mr. Nolan, I promised you. What did we promise you? We promised you that your most favoriteest thing in the world, y equals mx plus b, was coming back.
We didn't forget about it.
And did we lie? We did not lie. Here it is, okay? So guys, hey, what's the problem with trend lines? What's the problem with them?
Well, my trend line could be a little bit different than your trend line.
That's right.
That doesn't mean mine's wrong or yours is wrong.
That just means that they're inaccurate, so to speak, right? There's got to be a better way, okay, for us to use these. Anyway, and that's why we have the ability now to write equations for trend lines. And now we can use that equation to, answer stuff. Anyway, how do linear models help you make predictions? So guys, this is where we can use the trend line, all right, to, I don't know, this is going to be generic, guys. We can use our trend line to solve problems, right? So we don't draw a trend line for nothing. We are going to use that to make predictions, right? To say, oh, okay, this is the family's grocery cost per week. Well, if you had 7 children, well, we would predict that you would spend roughly this much money, right? That's what trend lines help me do. We can be more accurate if we make an equation for the trend line, okay? Because sometimes we're not really going to know. Like, guys, do you know what number this exactly is right here on the graph? I have no idea. It's some number that's greater than 210, okay? So if we have an equation, we can really find a very precise, we'll call it, answer.
Precise.
Okay. Here you go. How do you find the equation of a linear model when you are given the graph, but not given the equation? I don't either. Well, we're in Mr. Knoll's room. Does he have up his 4 steps? Oh, no, that's for the solving thing. So, guys, how are we going to write an equation? How do you find the equation line? So, in other words, like, how would we find the equation of this line?
Find the slope.
Oh, that sounds like a great, yeah, guys, it's really just about 4 steps. So step 1 is, sure, we'll just simplify it to say find slope. So you guys know you got to find 2 ordered pairs, y minus y over x minus x, okay? So we find the slope. Once we have slope, we will use y equals mx plus b, okay, and we will fill in numbers for y, m, and x, okay? Because what are we trying to do? Find the b. That's the y-intercept, okay? All right, that's step number 3 is find b, the y-intercept. Step 4, all you got to do left is the easy part, and that's write the equation, because you will know the slope and you will know the y-intercept, and you guys are all very, very proficient at that, okay?
Yeah.
So there's your 4 steps if you forget them. Find slope. Use our slope-intercept form, y equals mx plus b. We are replacing y, m, and x, okay, in that. Where do x and y come from? That's right, one of the ordered pairs I used to find slope, okay? All right. Can the linear model for a set of data that is represented in a scatter plot always be used to make a prediction about any x value? Predict any x value? Sure, absolutely, right? We would say yes.
Yeah.
Now, here's the deal, gang. There's these weird words we have that we call extrapolation and interpolation. We're not really going to go into either one of those, right? But if we are interpolating data from, like here, number of children, 1 through 6 is interpolation. Once we get outside of 6 and we're 7 through whatever, yeah, that's extrapolation.
Wow.
You wait till next year. You'll do a whole bunch more with that, okay? Or maybe you won't. Who's to say? Anyway, I think we're good there. But yeah, guys, that's why we spend so much time writing this equation or using our trend line is so that we can use it for anything, because it wouldn't make any sense if it only worked half the time. Could have said something really funny about it. Anyway, use the slope. Predict the difference in the amount spent on groceries between a family with 5 children and a family with 2 children. Now notice it says use the equation, right? If we were just going to use the trend line, guys, we would go, okay, hey, 5 kids, they spend roughly this much, okay? 2, yeah, 2, you spend roughly that much. And here's the problem with graphs, guys. What numbers are those? I don't know.
I don't know.
That's some number less than 140, and this is some number that's, less than 210. Who knows? Who knows? Okay? So that's why we have this fantastic equation here. So guys, I want you to pause the video. We are going to substitute 5. Again, 5 is should we substitute 5 in for x or for y?
It's on the x-axis.
That's right. If you're not sure, guys, hey, this says 5 children. Where is children? Is children a y or an x? Here it is on the x. So I want you to replace x with 5. Figure out what number this turns into. So in other words, multiply it by that 21.08, then add it to 85.15, right? Come up with that number. Remember it. Then I want you to repeat that process for a family that has 2 children in it. So again, replacing x with 2. Do some multiplying. Do some adding. So then you're going to have, hey, family of 2 spends this much money. Family of 5 spends this much money. And let's do a little bit of subtraction. Okay? A little bit of subtraction because it says predict the difference. And I know that difference means subtraction. Okay. So, no, seriously, pause it. Go. Do that. Bam. All right, you're back. Hey, good to see you. Hopefully you have your answer here. So, guys, if we're trying to predict the difference, right, let's just predict it to the nearest dollar. Let's just do that. Makes it easy on him, right, Mr. Knoll?
Oh, I think we can do it easier than that.
Okay, well, Mr. Knoll earlier, right, you guys don't understand how good he is at mental math. Anyway, this turns out to be, what, $63.24?
That's the difference.
Okay, that's the difference, exactly. If we said nearest dollar like I wanted to, be $63. Mr. Knoll never wants to do anything if it's not his idea, okay? Part B, how many children can you predict a family has if we spend $170 on groceries? I don't know. Well, if we're spending $170, which variable, right, is that represented by? Is that represented by my x or my y variable?
Definitely not the x value.
Amount spent on groceries. So we're going to do the exact opposite, okay, for part B. Guys, here I want you to take this $170 number, and I want you to replace y with it. And then what do you think I want you to do? Then I want you to solve that equation for x. Remember, x is the number of children, okay? Now, when you do that, hopefully you're going to get a number. We can't really have 3.75 when we get kids, right? So we're going to have to maybe do some rounding there. Anyway, pause the video, throw this number in there, right? You're going to do your little work, and then we'll see what you get, okay? All right, hey, welcome back.
Welcome back.
Well,
it's like you were never gone.
It's like they were gone, but they weren't gone. You know what I mean? Anyway, how many kids did you guys get? How many are you predicting? Family spends roughly $170.
5, I think. 5.
5? I'm going 4.
Oh!
I'm going 4.
Is that what you're going with?
Yep. You guys got the same thing, hopefully?
I thought you said I was good at math.
You are good at math. Anyway, okay, guys, hey, that's what we got going on. That was page 226. We've got more. Look, this ain't easy, right? I know 4.1 and 4.2 were awesome. Okay, now we get to 4.3. We get back into some good old 8th grade math that's a little bit more challenging. So let's have a good time with our additional practice and our other stuff as well.